Welcome, trig folks. Getting ready for this test coming up. I'm going to give you some examples from chapter 4 that hopefully will help you get ready for the test. Hopefully these examples might clear up some things that you may have missed out on or didn't know the questions to ask, but I think this will be a big help. So when we're talking about graphing these trig functions, as you know, we come back to this generic form of y equals a, parentheses, whatever my trig function is. In this case, I'm working with sine, b of x minus h. Now, it's important that that b is factored out of both of these and not just a number beside x. And then finally, k. So what are some of these things? Well, back in college algebra or algebra 2, you should have seen something like horizontal shift, amplitude, and vertical shift. You simply had hack, H-A-K. And the reason that I put it in that order is because when you graph these, you would be graphing from the inside, which is the H, out. So the H would get done first, then the B, then the A, and then finally the K on the end. Okay? So let's take a look at what we have. H, that's my horizontal shift, moving left and right. B, once I find out what B is, I'm going to use it to determine my period. If it's sine and cosine, I take 2 pi divided by B. If it's the tangent, I just take and divide pi by B to let me know. A is the amplitude. That's when I'm going to stretch it up and down at the same time. Finally, K is my vertical shift, which would move me up and down. All right, so if I take a look at this guy, I get y equals A, the cosine of B times x plus h plus k. So if I take a look at this, I'm going to say, all right, so there's nothing to factor out. My B is just going to be 1. So again, I'm going to go with h back, h-b-a-k, and let's see what I get for h. H should be, excuse me, this should be a minus. H is going to be the result here. So H is going to be negative pi over 2. That means the first thing I would do with my parent function cosine is I'm going to move it, the whole thing, to the left, pi over 2. The B, in this case, my B right here in front is equal to 1. So my period is going to be 2 pi divided by the B. Looks like my period is going to stay 2 pi. My A, in this case, is 3. So my stretching up and down, my amplitude would be 3. And finally, I have a K, and there's nothing out here on the end. So my K is going to be 0. I won't have any vertical shift. I won't be moving up or down. So again, if I was graphing this, I might take a look at the cosine. Here's 2 pi. We always put labels in. Here's 1, here's negative 1. Here would be pi. So this will be the graph of y equals the cosine of x. Then my next graph would be including the h. So now I'm going to look at y equals the cosine of x minus negative pi over 2, which I said I'm going to move the whole thing over pi over 2. So what was at 0 would now be at negative pi over 2. What was at pi over 2 will now be at 0. What was at pi will now be at pi over 2. What was at 3 pi over 2 will now be at pi. And what was at 2 pi over 2 will now be at 3 pi over 2. As a result, you'll see my graph has now shifted to the left pi over 2. My period doesn't change, so I don't need to stretch or shrink this. My amplitude is 3. So this originally was 1 and negative 1. Now it's going to be tripled up to 3. So what was at 1 would now be at 3. I'm going to have a graph that looks something like 1, 2, 3 for my high, 1, 2, 3 for my low. And then, of course, I'd put the graph and stretch it. So this is what I'm going to be looking for mainly on the test, because it's going to be hard to graph this. But once again, this graph would take up the parent, the horizontal shift. There's no change in period, so I don't need a graph for that. The amplitude, y equals 3 times the cosine of x plus pi over 2. This was negative pi over 2. Out here, this was 3 pi over 2, and this was pi over 2. So my graph would look something like this. Sorry for the roughness and the quickness, but I took care of that. So for this guy, I would need 3. And once again, k is 0, so I don't need to move it up or down. I'm going to take a look at another one real quick. Let's start with y equals 1/2 the cosecant of 2x minus pi over 4. Again, this has to fit the mold of y equals a, my function, cosecant of my b needs to pull out. So I'm going to divide this by 2 to pull it out, which means I divide this by 2. So when I divide it by 2, I'm going to get pi over 8. And again, there's nothing out here on the end for the k to shift me up or down. So when I get ready and start identifying this, I'm going to say my h, and again, I'm going with y equals a cosecant of b times x minus h plus k. So for this problem, my h is going to be just pi over 4, which tells me I'm going to go to the right. My b is going to be 2, and cosecant is 1 over sine. Its period is 2 pi. So my period here is going to be 2 pi over b, which is going to give me a period of pi. My a is 1/2, which means if I was graphing this, instead of going from 1 to -1, it would cut it in half. Or in this case, it's the graph with the cosecant with the values cut in half. And again, my k is 0. So on the test, you're going to see that this is a 5-point question. 1, 2, 3, 4, and 5. So that's the pieces of the translation of a trig function graph. I hope that helps you get ready for the test.